There's something universally captivating about rankings, isn't there?
Oh, definitely. We seem obsessed with them.
Yeah, whether you're trying to pick, like, the best blender on Amazon or find the top search result on Google or, well, obviously passionately arguing about your favorite sports team standing, rank is just everywhere.
It really is. It's how we structure a lot of things.
But here's the thing I always wonder. How accurate are they? Especially, when it comes to predicting what happens next.
That's the million-dollar question, really.
Okay, so let's unpack this. Today, we're doing a deep dive into the pretty rigorous science behind sports rankings. We're focusing specifically on their predictive power.
Right. Not just who's number one now, but how well does that ranking tell us who might win tomorrow?
Exactly. And our source for this is a really fascinating academic paper from 2013. It's called Ranking Rankings, an empirical comparison of the predictive power of sports ranking methods.
Quite a title. It's by Barrow, Dreyer, Elliott, Gout, and Osting.
Yeah. And our mission today is basically to understand how these researchers took 8 different sports ranking methods, and not just the basic ones. Some are seriously sophisticated algorithms, and put them through a really tough statistical test. We want to explore what they found, which methods actually get it right more often, and what that means for how we should think about rankings. Not just in sports, maybe elsewhere too.
And there's a key distinction they make right off the bat in the data they use, isn't there?
Ah, yes. The difference between just simple win-loss records versus the actual margin of victory, that turns out to be pretty important.
It really does. What's fascinating here is how these methods, they're all trying to rank teams, right?
Yeah.
But they come at it from fundamentally different angles.
Right.
And crucially, how much the type of data they feed into these methods changes how well they predict things.
Okay, so this is where it gets, really interesting. They didn't just look at 1 or 2 methods. They dug into 8 distinct algorithms, and each one had 2 different versions.
Exactly. 2 versions based on the data input.
So what was the difference there?
Okay, so they split the data into 2 types. First, you've got the alpha version. That uses simple win-loss data. Binary, basically to do win, lose, or tie. That's it.
The most basic record.
The most basic, yeah.
Yeah.
Then you have the beta version. This one's more granular. It uses score differential data, so the actual margin of victory or loss.
Ah, so winning by 20 points versus winning by 1 point.
Precisely. And intuitively, you'd think that contains a lot more information about how the game actually went, right? Beyond just who won.
Yeah, absolutely. So, okay, if you're listening, you're probably wondering what these 8 methods actually are. Can we quickly run through them?
Sure. First up is WBP, winning percentage, the most basic. Alpha version is just your percentage of games won. Beta version is your proportion of total points scored over the season.
This is kind of the we won, you lost method. Doesn't really care how or against who.
Pretty much. And crucially, like you hinted, it doesn't factor in strength of schedule at all. A high WP could just mean you played easy teams.
Okay. What's next?
Then there's RPI, the rating percentage index. This one's a bit more sophisticated. It looks at your winning percentage, plus your opponent's winning percentages, and your opponent's winning percentages.
So it tries to account for who you played.
Exactly. It's an attempt to factor that in. And again, alpha for win-loss, beta using score differentials instead of just wins.
Got it. Method 3.
L2, or least squares pairwise comparison. This is more statistical. It tries to find ratings for all teams where the difference between any 2 teams' ratings best matches the actual outcomes of the games played between them.
Like finding the best fit for all the results.
Yeah, that's a good way to put it. This method actually goes by other names, too, like the Massey rating. You might have heard of that one.
Ah, okay. And then MP, maximum posterior. Sounds Bayesian.
It is. It sort of builds on L2 but puts it in a Bayesian framework. Think of it like starting with a general idea about how good teams are and then updating that belief with each new game result. It's related to statistical ideas like ridge regression.
Interesting. Okay, what about K, Keener's direct method?
This one uses some fairly advanced math, the Perron-Frobenius eigenvector of a specific matrix. Basically, it tries to identify the most dominant pattern of wins and losses across the whole league network.
Dominant pattern.
Okay. Think of it like finding the central pillar of strength in the schedule.
Right. And then, okay, this one made me do a double take. PR, page rank. Like Google paid.
Yes, that page rank. The algorithm Google made famous for ranking web pages, they adapted it for sports.
How does that even work?
It uses a similar mathematical tool, that Perron-Frobenius eigenvector again, but applies it to what's called a stochastic matrix. Imagine a map where arrows point from loser to winner for each game. PageRank finds the teams that sort of have the most importance flow towards them in that network.
Huh. Okay. NRW, random walker.
This one imagines little walkers randomly moving between teams on a graph based on game results. If Team A beats Team B, a walker might move from B to A. The ranking comes from where these walkers tend to spend most of their time in the long run, the stationary state.
So which teams kind of attract the most attention or flow?
Kinda, yeah. It's about long-term probabilities in that game network.
And finally, ELO's method. Chess ratings. I know that one.
Exactly. Most people know it from chess or other games. It's iterative. Your team's rating goes up or down after each game based on the result compared to what was expected given the ratings. Beat a higher-rated team, you gain a lot of points. Lose to a lower-rated team, you lose a lot.
And they started everyone off the same.
Yeah, they initialized all teams at a 1500 rating and used pretty standard parameters for how much ratings change per game. K32, AIC 1000, for those interested in the details.
Wow. Okay. So that's 16 different ranking systems, 8 methods times 2 data types. How on earth did they actually test these? I mean, just comparing averages sounds way too simple for this level of detail.
You're right, it is. And that's a great question because comparing them reliably, that was a major part of the study. They needed a really robust approach.
So what did they do?
They went big, multi-sport, multi-season. They wanted findings that weren't just specific to, say, one weird football season.
Makes sense. Which sports and how much data?
A lot. They used 32 NBA seasons, going from 1980 right up to 2011.
Okay.
For MLB, 112 seasons. They looked at 1997-2012 overall, but also went back and analyzed the American League and National League separately from 1901 to 1996, because back then they didn't play each other much.
Wow. 112 seasons. That's comprehensive.
It is. Then for college sports, 22 NCAA Division I basketball seasons, NCAA-B, from 91 to 2012, and 56 NCAA Division 1A football seasons, NCAAF, that's 1956 to 2011.
Huge data sets.
Massive. And they were careful, too. They even pruned out teams that played very few games in a season, like fewer than 10 in NCAA-B or 4 in NCAAF, just to make sure the data quality was high.
Smart. So they have the rankings, they have the game data. How did they measure which ranking was better at predicting?
Their core metric was pretty straightforward. Predictive accuracy, defined as the proportion of games in a specific test set where the ranking correctly predicted the winner.
So if the ranking said Team A is better than Team B and Team A won, that's a correct prediction.
Exactly. Simple concept, but the testing was rigorous. They used 20-fold cross-validation. Okay, picture taking one season's data and splitting it into 20 chunks.
Okay.
They'd use 19 of those chunks to generate the ranking using a specific method. Then they'd test how well that ranking predicted the winners in the one chunk they held back the test set.
And they did that for all 20 chunks.
Yep, rotating which chunk was the test set. And they didn't just do it once per season. They repeated the whole 20-fold process 100 times per season, shuffling the data each time.
Whoa! Why so many times?
To get a really stable, reliable cross-validation score, it avoids the results being a fluke of just one particular way the data was split. Extremely thorough.
Okay, that's serious number crunching.
Yeah.
But it wasn't just about comparing the average scores, was it? They used some advanced stats tests, too.
Precisely. This is critical. Comparing averages can be misleading, especially with sports data where predictability can swing wildly year to year. They use non-parametric hypothesis testing.
Non-parametric, meaning
Meaning the tests don't rely on assumptions about how the data is distributed, like assuming it follows a nice bell curve. Sports results often don't, so these tests are much more reliable here.
Okay. Which tests?
First, they use the Friedman test. This test basically asks, are all these ranking methods performing the same, statistically speaking, or are there real differences in their predictive accuracy?
And what did it find? Spoiler alert.
Spoiler, no, they're not all the same. The Friedman test rejected that idea very strongly, like 99% confidence. The methods do differ in how well they predict winners.
Okay, so if they're different, how do you know which ones are better or worse?
That's where the second test comes in. The Nemni test. It's what's called a post hoc test. After Friedman says, yes, there are differences, Nemni goes in and does pairwise comparisons to pinpoint which specific methods are significantly better or worse than others.
Gotcha. So Friedman for the overall difference, Nemeni for the specific matchups between methods.
Exactly. It's a really robust way to compare them all fairly.
All right. So after all that meticulous data collection, cross-validation, these advanced statistical tests, what did they actually find? Did we finally get the secret sauce, the one ranking method to rule them all?
Well, the big picture answer is kind of nuanced, but really, really insightful.
Okay, hit me with the nuance.
First, and maybe this is the biggest headline, there isn't one single best ranking method that dominates across all sports. What works best for, say, college football might not be the top predictor for baseball.
Ah, okay, so no silver bullet. But they did find differences. The Friedman test showed that.
Absolutely. They are definitely not all created equal. The way they rank teams and predict outcomes does differ significantly.
What was the most important factor driving those differences?
Okay, here's a huge takeaway, maybe the most practical one for anyone following sports rankings.
Yeah.
The type of data matters a lot.
The alpha versus beta thing. Win-loss versus score difference.
Exactly, especially for NCAA football, NCAA-F, and an NCAA basketball, NCAA-B. For those college sports, the methods using score differential data, the beta versions, were usually significantly more predictive than the ones using just win-loss data, the alpha versions.
Wow. So knowing how much a team won or lost by gives a much clearer picture for predicting college games.
It seems so. Think about it, a 3-point win is very different from a 30-point blowout, right? The beta methods capture that difference, and it seems to improve predictions, especially in college sports.
That really makes you think. If the beta versions, the score difference ones, are usually better for college sports, why do some official systems, like maybe parts of the old BCS or even current ones, sometimes rely more on just win-loss components?
That's an excellent point, and the study really highlights that tension. It makes you wonder about the criteria used for choosing official systems. Is it purely predictive power, or are other factors like simplicity, tradition, or maybe even politics involved?
Good question. Did they find specific methods that stood out for particular sports?
They did. For NCAAF college football, 2 methods using score differentials, the least squares, L2, and the random walker, were found to be significantly better predictors than the others with 95% confidence.
L2 and RW for football, okay? What about college basketball?
For NCAA-B, several of the beta methods performed very well. RPI, L2, MP, and RW all had really high predictive accuracy.
So again, the score difference methods are shining.
Yes, and here's a kicker. The study found that L2 and RW were actually more predictive than the RP method.
Wait, RPI? Isn't a version of RPI the official ranking used for NCAA basketball tournament selection for a long time?
Bingo. A variant of RPI was a key component. So this study suggests that other methods, particularly those using score differentials, could potentially predict game outcomes even better than the official standard, or at least a standard based purely on win-loss.
That is really surprising. What about the pro leagues, NBA and MLB?
It was a bit different there. For the NBA and MLB, the Nemeni test often had a harder time pinpointing one single method that was significantly better than all the rest. Instead, it was often more likely to identify methods that were significantly worse.
Ah, so it's less about finding the absolute best and more about avoiding the clearly bad ones in pro sports.
That seems to be the pattern. It suggests that for the pros, maybe several of the reasonably sophisticated methods perform quite similarly well, but you definitely want to steer clear of the overly simplistic ones.
Did they find differences in just how predictable the sports were overall?
Yes, MLB games were generally found to be less predictable than the other sports. The cross-validation scores were just lower across the board for baseball, no matter which ranking method they used.
So that feeling that anything can happen in baseball might actually have some statistical backing.
It seems that way. And another related point, predictability varies by season too. Some years, in any sport, are just inherently more predictable than others, regardless of the ranking system. You have dominant teams, fewer upsets.
Those are some really powerful takeaways. It feels like it challenges a lot of gut feelings about rankings. Were there any other, maybe more subtle or technical findings that caught your eye?
Yeah, a couple of interesting nuances came up. One was about something called algebraic connectivity. It's a mathematical measure of how well connected the schedule graph is. Like, do teams play a wide variety of opponents, or are they stuck in isolated conferences?
Okay. How did that relate?
The study found that sports with schedules that had small algebraic connectivity, think college sports with lots of conference play and fewer cross-conference games, tended to have more variability in how well the different ranking methods performed.
So a less connected schedule makes it harder for all methods to agree, or perform consistently.
Kind of. It seems like when the schedule itself doesn't provide as much comparative information between all teams, the specific assumptions and approaches of each ranking method become more critical, leading to bigger performance differences between them.
That makes intuitive sense.
And,
Any other quirks?
well, remember PageRank. The PageRank beta erupt version, when using score differentials, actually performed worse than the alpha version for NBA data.
Worse, but score data was better elsewhere.
Yeah, it was counterintuitive.
Mhm.
Their explanation was that NBA score differentials are often relatively small compared to, say, college football. This makes the direction of the win less pronounced, and the PageRank algorithm, which relies heavily on that directionality, like a link from loser to winner, might get weakened when the scores are close.
Huh. So sometimes more data isn't automatically better if it doesn't quite fit the algorithm's logic.
Exactly. And one last thing. They also checked if methods that had similar predictive scores actually produced similar rankings.
Meaning, did they put the teams in roughly the same order?
Right. And the answer was often no. They used a measure called Kendall-Tau distance. For MLB, for instance, many methods had similar prediction accuracy scores, but the actual rankings they produced could be quite different.
So two systems might both predict winners correctly 60% of the time, but one might have Team X ranked 5th and the other has them 15th.
Precisely. It shows there's more to a ranking than just its raw predictive score. The actual order matters, too.
Wow. This deep dive really, it hammers home that ranking isn't just some simple list. The how is just as important as the what. How you crunch the numbers matters immensely.
Absolutely. We've clearly seen that not all methods are the same, and that crucial choice between using simple win-loss versus detailed score differentials that can be a real game changer, especially, it seems, for college basketball and football, where schedules might be less dense.
So, okay, wrapping this up, what does this all mean for you listening right now? I think this deep dive really shows that ranking is a complex science. It's not just an art form.
Definitely.
When you see a sports ranking next time, whether it's the official poll or some fan site's list, maybe ask yourself, is this based on just wins and losses, or does it account for how much teams won by? That knowledge alone might give you a better sense of its potential accuracy, particularly for college sports.
And it really highlights the power of doing this kind of rigorous statistical testing, doesn't it? Moving beyond just intuition or tradition to figure out what actually works best for prediction.
It does. And it makes you think. The study authors mentioned that these kinds of ranking algorithms are everywhere now, web search, e-commerce recommendations.
Right. It's not just sports.
So here's a final thought to maybe mull over. If we can statistically prove that certain methods are significantly better at predicting sports outcomes, what might happen if other fields, other industries, apply the same level of rigorous comparative evaluation to their ranking systems?
That's a great question. Think about product reviews, search results, maybe even college admissions rankings. Could they be significantly improved?
Yeah, what official rankings in your daily life might look completely different if they incorporated more nuanced data or just used a statistically better algorithm? Something to think about until our next deep dive.